So in this video, I'm going to explain about how to find the equation of a plane in 3D, and the data provided might differ, but we can bring all of them to one single form, like first of all trying to figure out what is the vector that is going to be perpendicular to the required plane. Let this be the vector which is perpendicular to the required plane, and let me choose a point, say A, whose position vector along the three directions, that is the components along the three directions, be taken as x naught, y naught, z naught, and let this normal vector have the direction ratios as ai plus bj, or the direction ratios are abc, and the vector normal to the plane is ai plus bj plus ck. Now let me now choose an arbitrary point on the plane and let it have position vectors x, y, z. Of course, since I have chosen P as an arbitrary point, it might have any coordinate. That is why I'm taking it as x, y, z, some unknown point. And now let me join AP, so that now I will have AP vector dot n vector equal to 0, because AP is a vector lying in the plane and n is a vector normal to the plane. Now using the position vector, this will reduce to OP minus OA dot n vector equal to 0, and writing it in terms of its components xi plus yj plus zk minus, this is going to be x naught I plus y naught j plus z naught k equal to 0. Sorry, dot n. I missed the dot n. That is the dot product with n. So dot n is going to be therefore ai plus bj plus ck. The dot product with that equal, it's going to be equal to 0. Now I am going to isolate all I terms separately, j separately, k separately, because we know that I dot I equal to j dot j equal to k equal to 1. Whereas when we take the dot product with I with j, j with k, or k with I, that will become 0, since I, j, k are mutually perpendicular vectors. Now opening this, x minus x naught times a, because this I xi and this x naught I put together, taking dot product with a, is going to give me a times x minus x naught and I dot I, but I dot I being equal to 1, I am just going to write it as x minus x naught times a plus y minus y naught times b. Again, the same thing happens for j component also. And the last one, z minus z naught with c vector equal, that is, sorry, the c coefficient equal to 0. So the equation of the plane, which has a normal vector as ai plus bj plus ck, and if it passes through the point x naught, y naught, z naught, the equation of the plane, it can be written in the form of a times x minus x naught plus b times y minus y naught plus c times z minus z naught equal to 0. And this can also be written in the vector form. That is, I'm going to write it in the vector form as taking OP as R vector and OA as A vector dot n vector equal to 0. I need a bracket here. So won't this become R dot n minus A dot n equal to 0? Or I can rewrite this as R dot n equal to A dot n. This is the vector form of the equation of the plane when we are given the normal to the plane and also one point lying on the plane.